Hello, Calculus 1. I want to move into, we're doing limits in Chapter 2, and I want to move into Section 2.5 is a new idea, kind of a new idea, infinite limits. So I want to start with this one over here. This is a limit as x approaches 2 from the left. We use a lot of one-sided limits up here in 2.5, not all of them, but a lot of one-sided limits come into play. So this is a limit as x approaches 2 from the left of this 1 over x minus 2. So remember, my advice on limits, step 1 is you plug it in and see what you get. Now this is going to be kind of new to us. Watch. If you plug in the 2, I know it's from the left, but you still plug in a 2. You plug in a 2 and you get 0 in your denominator. So you get this 1 over 0. Now we've dealt with 0 over 0 as an indeterminate form that we often would figure out. We would do some factoring, we'd do some multiply by the conjugate, do some common denominator. There's a lot of work we can do to figure out 0 over 0, special trig theorems, all kinds of stuff. But a number over 0, all in your pre-calculus days, has been quote-unquote undefined. But with limits, we can figure out what it is. A 1 over 0, how about this? How about you think of that 0 as not really ever being 0? As x gets really close to 2 from the left, we're approaching 2 from the left. We're at 1.9999999, and we plug it in and we subtract 2. We get this teeny little number. We call it 0, but can we pretend it's a teeny little number? And then I want to know if it's positive or negative. Well, hang on a second. If it is a teeny little number, how many times does it divide into 1? I think a lot. I think infinite. The answer to this is infinity. The debate is whether it's positive infinity or negative infinity. Hang on. If I'm coming from the left and I'm at 1.999 and I subtract 2, I'm at a little negative 0.001. So it's a teeny little negative number. When a negative divides into a positive, the answer is negative. It's negative infinity. The answer to this is negative infinity. It's a number over 0, which makes me think of infinity in limits, and it's and I have figured out the sign of that teeny little number, and I figured out it's negative infinity. It's almost like I did it numerically, you know, because I plugged in a little 1.999. So it's kind of like I'm doing it numerically, but that is the analytic way to do it. There is no other way to do this problem. Let's try this one. The limit as x approaches 4 from the right. Okay. Step 1 of any limit, plug it in, see what you get. If I plug a 4 in there, it's a 4. Plug in a 4. Although when I get to looking at it in detail, I'm approaching 4 from the right. Let me just draw a picture. I like to draw a little picture. So I'm approaching 4 from the right, like 4.01. But first you just plug in a 4, and you do get a 20 in the numerator and a 0 in the denominator. Again, a number over 0 makes me think of infinity. Whether it's positive or negative infinity, let's see here. If I'm coming to it from the right, I'm a 4.01. When you plug in a little 4.01, 4 minus 4.0, because of the subtractions a little backwards this time, I get a little negative number. I get a little negative 0. I mean, it's a negative, teeny little quantity close to 0. And it divides into 20 1,000 million times. The answer's infinity. But because of the sign difference, it's negative infinity. So this one's also negative infinity. Now listen, what's interesting is there was a couple one-sided limits back in section 2.4. And in section 2.4, you would get something like this, and they haven't taught you how to analyze it yet. They hadn't taught you infinite limits yet. And they want you to say, when you get this answer back in 2.4, they want you to say the answer does not exist. And so the books, I don't know, it's a little inconsistent. At first they say an infinite answer does not exist, and I see their point. It's not a number that you approach. But by telling me the answer is negative infinity, you're telling me the behavior of the graph as x approaches 4 from the right. So I want to know the answer is negative infinity. I don't want the answer dne. And they don't either. Once they move into 2.5, they start talking like this. You know, we could do another problem. They're easy to do. You think of a number over 0 now as infinity, and you analyze it close to see if it's positive or negative infinity. The other thing that's going on is, you know, these functions, what's happening with these infinite limits visually is this is happening around a vertical asymptote. You know, when this function is undefined at 2, what's happening is there's a vertical asymptote at 2. And you know what happens around a vertical asymptote, I think. As you approach 2, it goes up toward infinity or down to negative infinity. Now, from what I just learned here, hang on, I just learned this from this problem, is if I'm approaching 2 from the left, I'm approaching negative infinity. So I just learned that this is the look here. As I approach 2 from the left, it's negative infinity. This side's probably going up to positive infinity. I could investigate it numerically, analytically, or I could look at a graph. But that's what's happening here too. There's an undefined place at 4. The function is undefined at 4. It's actually a vertical asymptote at 4. That's why we get this infinite behavior for the limits. And this time, let's just look at a picture. This time at 4, there's a vertical asymptote. And this time, as you approach 4 from the right, we got negative infinity. So as I approach 4, so anyway, something was reversed. Remember, this was reversed. So this one probably goes up to positive infinity, although I haven't done 4 from the left yet. But I can sort of do it in my head quickly. There's a little more interesting problem here about the theory of relativity. This is from the book, number 60. I think it's in your homework. Before I get there, I think I can get there, but let me try one more of these here. So let's do another one here. I'm going to make up another problem. Sorry, I'm erasing. Should have warned you I was erasing this. I'm erasing this. It's already erased. Just make up another one for fun here real quick. Maybe it won't be real quick. Let's see. The limit as x approaches 3 of x over x minus 3 squared. All right, this is pretty good. All right, what do? Step 1, doing a limit. Step 1, plug in a 3, see what you get. I mean, if you get 7/9, the answer is 7/9. If you get 4, the answer is 4. If you get 0 over 0, you need to try to work on it analytically, try to figure it out. If you get a number over 0, it's infinity, and we kind of got to decide positive or negative. Anyway, here we go. We plug in the 3, and we do get a 3 over 0. So that's interesting. I'm thinking this is infinity, but I kind of don't know if it's positive or negative infinity. In fact, the way you tell if it's positive or negative infinity is you investigate the limit from the left and the right. And see, this one's interesting. This is not a one-sided limit. This was a two-sided limit. But in order to do it, I feel like I got to go investigate x approaches 3 from the left. Let's do that problem. And then we'll do limit as x approaches 3 from the right. Then we'll do that problem. Remember, the idea is if the left and the right are the same answer, then that's the answer. If the left and the right limits, if the one-sided limits are different answers, I think we should say this doesn't. That's when we say this does not exist. Let's try it. If I approach 3 from the left, now hang on, it's still a positive 3, but I'm just approaching from the left, so I'm at like 2.99. When I subtract 3, I'm a teeny little negative number, but then I square it, so I'm a teeny little positive number. So that's a positive little number going into 3. The answer is positive infinity. What happens when you approach 3 from the right? It's still a 3 in the numerator. In the denominator, it's a 3.01 minus 3. That's a teeny little positive number, but then you're squaring it, so it's a teeny little positive number. That's positive infinity. The limit from the left, the limit from the right are both positive infinity. Therefore, I think I would say this answer is positive infinity. Yeah. The picture is, just for fun here, the picture, it would be at 3 again. I'm undefined and it's a vertical asymptote. You remember, if it's undefined but can cancel away somehow, those were holes. But these undefined places that don't cancel away are vertical asymptotes. And this time, though, from the left and the right, both of them are approaching positive infinity. So in a way, you know, earlier in the book they say that limit does not exist. And I get them. It does, all right, there is no y value. The function has unbounded behavior. But this is my new way of saying the function has unbounded behavior, by saying the answer to the limit is positive infinity from both sides. Okay, so that's good stuff, you guys. Let's try this problem. It looks like it's a little scary and challenging. It's the theory of relativity. What it says is the mass depends on the speed at which you're traveling. That's what this says. So according to the theory of relativity, as we approach the speed of light, our mass changes. If we're traveling at higher and higher velocities, our speed changes. I mean, our mass changes. I'm not sure if it decreases or anything. Let's check this out. So this m naught is m with a subscript 0. Sometimes I say m naught or m sub 0. That's the way we talk. What it said in the problem was that's the mass when the velocity is 0. Let's just try that. If the velocity is 0, that's the variable v. You plug in a 0, that's a 0. 1 minus 0, that's a 1. The square root of 1's 1. The mass turns out to be m naught, or m sub 0. So when v is 0, that's our mass right there. By the way, c is the speed of light, which is a constant. It's huge number, and m is the mass. So the variables are m and v, and so as v changes, our m should change. Now I think what they say is let's approach the speed of light. Let's let v get huge and see what happens. Before I do that, let me try one thing that the book didn't say. The question didn't say this. This is in your homework. Let's try what happens if we're at half the speed of light. I just want to try that. If I'm at half the speed of light, I want to see what the mass is. Okay, if I'm at so the velocity is half the speed of light. All right, hang on. Got to do some work here. So half the speed of light, that's 1/2 c. Hang on. 1/2 c. That's the velocity, and I'm going to square it all over c squared. Well, guess what? Those c squareds cancel. And I get 1/2 squared, which is 1/4. So I just got the m naught over, hang on, 1 minus 1/4, the square root of 3/4. Or m naught, the square root of 3 over 2. Or, if I flip that up, 2m naught over the square root of 3. Now, I'm not sure what that is. I am sure what that is. The square root of 3 is 1.7. So this 2 over this 1.7, this is bigger than 1. So it's slightly bigger than the original mass. It's 2 over the square root of 3. Let me see. Let me see what that is real quick. Hang on. Yeah, about 1.15. So this is about 1.15 m naught. So whatever the original mass was, it's increased slightly. So as our speed increases, our mass begins to increase. Wow, okay. Our mass begins to increase as we get toward the speed of light. You got to get close to the speed of light. You don't notice this as you're driving around town or running down the road. So you got to get to half the speed of light for it to increase a little bit. And what happens, they want me to do this. What's the limit as the v approaches the speed of light? By the way, the speed of light's the fastest velocity that we know of. So when we approach the speed of light, we have to approach it from the left. You're never on the other side of the speed of light. So you're approaching the speed of light from the left, little detail there. And I'm going to take the limit of this. It's m naught over 1 minus v squared over c squared square rooted. Well, here we go. I'm going to just plug in a c. That's what I do. I plug in a c for the v. I get c squared over c squared. That's a 1. 1 minus 1 is a 0. I get this number over 0. And I've been trying to teach you in limit world, that's infinity. And is it positive infinity or negative infinity? That's debatable, but hold on. If we're approaching this speed of light from the left, then we're just always a little bit less than the speed of light. So this is always a little less than 1. So when I subtract it from 1, I'm always a teeny little positive number. Of course, I have to be to take the square root of it anyway in the real number system. So this is a teeny little positive number, and this is positive infinity. So if we're a mass and our v approaches the speed of light, our mass approaches infinity. Mass is relative. Wow, that's fun. I appreciate it, you guys. That's the end of this video. And we'll do some more stuff. We might move into chapter 3 next.